Welcome to the notes for section 8-7. Today we're going to look a little bit more at the number e, logs, natural logs, and solving equations that have them in there. Let's look at some review of some of the properties first. We have simplify each expression. Okay, looking back at the 5th section of this chapter, we looked at natural logs of e to exponents, right? Remember, this is just a log statement, and when our value in a log statement has an exponent, we can take it and move it out as the coefficient. So it would be like 4 times the natural log of e, which we know is 1, and that gets us a value of 4. In the second one, we had 2 times the natural log of e to the negative second plus 3. Let's focus on this part of it first, right? I have my 2 times, well, this is just in the same situation we had in that first example. We're going to move this exponent out in front as the coefficient, and then we have the natural log of e, which we know is just 1, right? So when we take this and we simplify it down, it's just 2 times negative 2 plus 3, or negative 4 plus 3, which gives us negative 1. Remember, in the last section of notes, we also talked about that property, right? When we take the natural log of e raised to the power of p, it's always going to equal p. Okay, it's very similar to when we do log base something, right? Of something raised to a power, right? It's always going to equal p as well. This one, we just know what the base is. The base that we're looking at there is base e. Okay, so this is just another way of writing logs of something there. We're just using natural logs instead. So let's move on. I'm going to have you pause the video after I read the directions, and I'm going to have you just find the values of these expressions on your calculator. So it says simplify each expression using a calculator. When necessary, use your results to write the rule. Go ahead and pause it and work through. All right, hopefully you're finished and you're ready to go. With your first one, you had 4 raised to the power of log base 4 of 9, and you should have ended up with 9. The second one, 2 raised to the power of log base 2 of 7 equaled 7, and then this one ended up equaling 12. Okay, so as we look at that, we're just noticing that it's like an exponential expression. Your base has a 4 in it, and then you have a log of base 4 up here, right? So it's kind of like they're canceling each other out, and we're left with the value that's in the log. Okay, and that happens each time on this. So, our 2 and our log base 2, it's like they're inverse operations of each other, and the thing that we're left over with is going to be our answer. So when you're talking about what is the rule, right, a raised to the power of log base a of x, we know ends up equaling x. And on the right side, it's very similar, except now we know that the base is e, right? So we're talking about e raised to the power of natural log of 4. That's like e to the power of log base e of 4, right? In which case now it just follows this exact same rule. We have the same base here and here, so we knew that we got 4 when we typed it in. Okay, but you just typed it in this way, hopefully. And then this one should have been 5, and this one should have been 10, which means that the rule, when you have e raised to the power of the natural log of something, okay, whatever you're taking the natural log of is going to end up being the answer. Okay, so really this rule on the left and the rule on the right are the same thing. In this one, we just know that it is base e. Right? Over here, for this, a could be any base, any number. Okay, so let's practice with it a little bit. It says, can we apply our new rule on these two? We have e raised to the power of the negative natural log of 5. Let's start out by just looking at the exponent. Right? When I say a negative natural log of 5, I know that's the same thing as saying negative 1 times the natural log of 5, in which case I can take my coefficient and move it up here and make it my exponent. So I have the natural log of 5 to the negative first power. When we apply the rule from the previous slide, we know that this is e raised to the power of the natural log of 5 to the negative first power. Well, remember, this is e raised to the natural log here, so it's like they're going to cancel out, and our answer, right, should be that 5 to the negative first, and then we can just simplify and get rid of our negative exponent. We know that's going to end up being 1/5. The second problem, we have 2 times e raised to the power of 2 times the natural log of 5. Well, going along the same lines as the previous problem, right, I'm just going to leave my 2 that's out in front here alone for a moment. But I know this is going to be e raised to the power of the natural log of 5 squared, right? Because I took this 2 and I moved it back up here as the exponent. In which case, then e raised to the power of the natural log, or log base e up there, right? That means that that's going to have a value of 5 squared. So I have 2 times 5 squared, which is like 2 times 25, or 50. And that should be our value. Okay, so we really know all of these rules already, but we're just going to have to manipulate our expressions so that we can apply these rules. So this one says, use your knowledge of natural logarithms to solve each equation. Check it on a graphing calculator. So the first one, the natural log of x equals -2. And when we think about the natural log of x, remember that is like, we have like a base e, right? It's like log base e. So when we have a log expression, right, and there's just one on the side, and we're trying to solve it, we can change its form. We can say, hey, this is going to be e to the -2 equals x. Right? And so do we need to take it and change it around? No, we can just leave it as the exact answer is e to the -2. But let's check it out here and see what we get. And pull out my calculator. Right? We know that e to the -2 is approximately, let's see, we've got second e, we're going to raise it to the -2 power, right? About 0.135. Okay, so it's about 0.135. Okay, and you can solve this a couple different ways. If you wanted to solve it, you could use your solver, or you could take it in, you can graph it. I know a lot of you are real comfortable with that. So you could do the natural log of x. And if I took it and I set it equal to 0, I would add 2, right? So we can look for where it crosses the x-axis. So let's see, got it. Here's our graph. If I go on here and I trace it down to see my root, if it wants to cooperate with me, you see up at the top there, you get that value, x is 0.135. All right, the next one, we have e to the power of x equals 1/2. Okay, this one's a little bit different, right? I treat this one more like it's in an exponential form versus a log form on the previous one. What we need to do is we need to get this x out of here. So we could do this a couple different ways. One thing we could think about doing is going ahead and taking log base e, or the natural log of e to the power of x. But if I do that on the left side, remember I also have to do it on the right side to keep that balance in the equation. But now that we have that, right, we can take that and move that out in front. And we're to the point now where you don't have to tell me x times the natural log of e anymore. I know that this ends up equaling x. And then on this side, we have the natural log of 1/2. So this is going to be our exact answer. We know that one's going to be a decimal as well. And let's just take a little peek here and see what the actual value of that would be. Just good practice with our calculator, right? We're going to do the natural log of 1/2. We graph it. Oops, I'm sorry, I'm not graphing it. I was just pressing enter. So it's about -0.693. And if we just type it in up here, we could do our natural log of, actually, I'm sorry, I'm doing the wrong equation. We're doing our original equation up here. So, right, So that'd be second e to the power of x, and then we would have minus 1/2. And when we look at our graph here and we look at where it crosses the x-axis, hey, negative 0.693 also. Right, so moving on, looking at the next one, right? So down in the bottom left corner, this one's very similar. We have an exponential, right? It's e raised to the power of 2x plus 1 equals 4. So again, you're going to do the same thing that we just did. Let's take it, and we could say this is like the natural log of e raised to the power of 2x plus 1 is equal to the natural log of 4. In which case, right, here's our coefficient. Natural log of e is 1, so that we'll just take this and turn it into 2x plus 1 is equal to the natural log of 4. And when you do this part, please be careful, right? Because I'm going to take away 1 from each side, but I can't take away 1 from the 4. I'm taking the natural log of 4. So I'm going to put parentheses around that 4, then put minus 1. Right? That still equals 2x, and then we'll just divide each side by 2. And our value is going to be x equals the natural log of 4 minus 1 all over 2. I think you get the gist on checking it with the calculator. I'm going to let that go. And let's look at the last one. Now we're back to a log expression. We have the natural log of x plus 1 is equal to 3. So remember, when it's in log form, we want to turn it into exponential form. This is like base e. So e to the third power should equal x plus 1. And now to solve it for x, we'll just take away 1 from each side. And we get e to the third power minus 1 equals our x. And our x should be in the same line if it's an equation. All right, so at this point, I'm going to give you some to try on your own. So you can pause the video and then I'll walk through them. You can pause the video and try all of the rest of them if you want, and then just fast forward. If you feel like you've already got the gist of things there and you want to start working on your worksheet, you may do that as well. I'm still going to work through all of these in case anybody has questions, but if you feel like you've got it down, go ahead and do it, and you can check your answers. If you're not understanding, come back to the video and you can watch me work through some of the examples if you need to. All right, so here I go. It says try these on your own. It says solve for x. Okay, so we've got e raised to the power of 2x equals 4. We need to get it out. So again, we're going to take our natural log of e to the power of 2x should equal the natural log of 4. It's very similar to the ones on the previous page, but we know that this is going to become our coefficient and end up multiplying times 1 to give us 2x. Equals the natural log of 4, and then we'll just end up dividing each side by 2. So x is going to equal the natural log of 4 divided by 2. All right, so the next one, 1 plus the natural log of x equals negative 2. Right, so just like any other log equation, we need to get the log by itself. So we're going to subtract that 1 from each side. So now that we have that natural log of x is equal to negative 3, and now we can remember to change its form back to exponential. Think about log base e to this power should equal this. So we've got e to the negative third power is going to equal x. And that is our answer on that one. Now, you can always take it, plug them back in to check them. Watch this, right? We've got 1 plus the natural log of, now it's going to be e to the negative third power is equal to negative 2. Right? Well, there's our exponent, right? It'll become our coefficient. So we have 1 plus a negative 3 equals negative 2, and we see that that is a true statement. So even if you don't have a calculator, you can still check these ones. All right, next part says solve each equation. The first couple are just using properties that we already know from algebra. We have x times the quantity of x minus 4 equals 0. And we know since this one's already factored for us, we can just use our zero product property and set each factor equal to 0. So we have x equals 0 and x minus 4 equals 0. So x equals 0 and x equals 4. For the second one, we're still just going to use our zero product property, right? We have e to the power of x times the quantity of x minus 4. And since that equals 0, we know that either e to the x equals 0 or x minus 4 equals 0. Well, x minus 4 equals 0 we know is going to give us x equals 4. But e to the power of x equals 0, thinking about that for a moment, can we raise e to some exponent and get 0? Remember, this is an exponential function. We graphed this, y equals e to the power of x multiple times. Remember, it goes through that 0.10. It's got that exponential curve to it. Goes up like this, okay? Never touches the x-axis, so it never has an output of 0. So since it doesn't touch the x-axis, we'll say that that part has no solution. So our only answer in this case then would be x equals 4. Box those answers in too. All right, the next one, we have 3 times e to the power of x minus x times the power of, times x times e to the power of x equals 0. All right, well, let's try to make it look like the previous two equations, right? We've got common factor here and here. Let's factor that out. E to the power of x times the quantity of 3 minus x equals 0. And again, zero product property comes into play. We'll get in this case that x equals 3. And again, e to the power of x cannot equal 0, so that one has no solution for that part of it. So the only answer we would have there is x equals 3. The directions here state, in each equation, isolate the variable y, where the natural log of y plus 1 is equal to 4x minus 2. So we're not trying to get like a numerical answer. We are just trying to isolate y in these equations. So the first thing we're going to need to do on this problem is we're going to need to find a way to get y out of the grouping symbols. So if I have the natural log of the quantity y plus 1 equals 4x minus 2, I'm going to take it and try to rewrite it as an exponential, right? This would be e raised to the power of everything on this side should equal our value. So e raised to the power of 4x minus 2 should equal y plus 1. And now it looks like it's much easier to do. We'll just subtract 1 from each side, and we have e to the power of 4x minus 2 minus 1 equals y. The next example, e raised to the power of y minus 12 equals 3x. So we don't have any logs in this one. This one is exponential. So a lot of times when we have exponentials, we want to rewrite them as logs. So let's get our y out of the exponent by taking our natural log of each side. That's going to move our coefficient out. And since natural log of e is 1, we have y minus 12 is going to equal the natural log of 3x. And then we'll just add 12 to each side. And please be careful when you write your answer. Y equals the natural log of 3x. And I'm putting that 3x in parentheses because I don't want to make it look like I'm taking the natural log of more than just that 3x, because we're just adding 12 in the end. All right, next problems we have. I believe this is the last slide. So if you've been following along and you just want to try them on your own first, go for it. I'll work through it now. So I have the natural log of 1 over y equals 5 minus the square root of x. Okay, so it's a log equation. I have one log on one side So I'm going to go ahead and treat it like it's like a base e. E to the power of this side should equal this. So e raised to the power of 5 minus the square root of x is going to equal 1 over y. And now I need to think about, well, what do I need to do to isolate y? I need to get y out of the denominator. Well, we do have just a proportion here, right? We have a numerator and a denominator equals a numerator over denominator. And we know with the properties of proportions, we can take it and just go ahead and flip-flop, any numerator with the opposite denominator. And when we do that, you're going to see we're going to have y equals 1 over e raised to the power of 5 minus the square root of x. You get the same thing by cross multiplying. So if you're kind of freaking out, like, wait, what is that? Now, does this one simplify down? It certainly does. We could simplify this down a little bit more, or you could leave it like this, right? This would be the same thing as saying y is equal to, let's see, when we take an expression like this and we move it to the numerator, it makes our exponent negative. So we could say this is y equals e raised to the power of negative quantity 5 minus the square root of x. Or I guess you could even like distribute that through and say this is like y is equal to e raised to the power of square root of x minus 5, or negative 5 plus the square root of x. Any one of those answers would be just fine. All right, last one. We have the natural log of the square root of y minus 8 equals the sine of x plus x over 7. Lots of stuff going on, but again, we have on this side of our equation that single log, and there are no more logs in this entire equation. So if we have just that single log on this side and no coefficients to worry about, let's just do what we've been doing the whole time. We're going to take e, raise it to the power of what's on this side, set it equal to the value of the log. So e raised to the power of the sine of x plus x over 7 is going to equal the square root of y minus 8. We'll add our 8 to each side. E to the power of the sine of x plus x over 7 plus 8 is equal to the square root of y. And then the last thing we would need to do on this is square both sides. So you should get y is equal to e to the power of the sine of x plus x over 7. And then we'd have a plus 8, and that entire expression would be squared. That's it. So if you have questions, please make sure you mark them down. I'd be happy to answer whatever you need help with. Thanks for watching.